Vice President Joe Biden, what great pleasure and honor to start actually the 46th annual meeting of the World Economic Forum with this particular session. As you know, the forum is committed to address the big challenges in the world, and I couldn't imagine more important challenges than to make sure that we prevent, that we are capable to eradicate at the end cancer. I think everybody, directly or indirectly, is affected by it. So we are proud, and I know you were asked to take mission control by the president when he announced this initiative last week, only last week in the State of the Union message. And there was one national event, chaired, I think, by you, Professor Collins. And here there's the first international event. And it's taking place not only with the best scientists, experts, it's taking place in a multi-stakeholder setting, because we know in order to really address this issue, it needs an ecosystem, it needs the engagement of all stakeholders, and particularly also of the business community. So thank you again for being here, and we can assure you that we will continue to support with all our heart this project and this important initiative in the future.
Well, Klaus, thank you. Thank you. Thank you very, very much. I am the late Joe Biden, and I sincerely apologize. But it's all Klaus's fault. And let me explain why. It took me about a half an hour to get from my hotel to here because there's bumper-to-bumper traffic. He's made Davos so important, so many leaders show up, that even with the Secret Service scheduling, I could not get here earlier. I truly, truly apologize. And I can say this to a Nobel laureate. In the United States, as you know, you only have to wait 20 minutes for a full professor. I'm not even a full professor. And so I am flattered any of you are still here. Thank you very, very, very much. I truly am sorry. I'm embarrassed. But look, almost everyone in the world, as you all know, has a family member who's had cancer. Every year around the world, 14 million people are diagnosed with cancer. And 8 million people succumb to it, die from cancer. And like many of you, I've experienced in my family the dreaded C word that I think is the most frightening word that most people, as these doctors and scientists can tell you, the most frightening word anyone wants to hear walking out of a doctor's office. And when I decided not to seek the nomination of my party, the president and I walked out in the Rose Garden to make the announcement, and I said, and it was almost spontaneous, that had I run, I would have liked to have been the president that literally changed the face of cancer. I realize there have been many moonshots. There's been a lot of talk about it. But the truth of the matter is that I said I believe that we need a moonshot in this country, an absolute national commitment to end cancer as we know it. I'm not naive to think that, as someone suggested, that we're going to have a cure to every cancer in the world, that that's going to come in the near term. That's not what is happening. But I must admit, I was absolutely dumbfounded by the international reaction. I literally heard from thousands of people. I heard from a group of a dozen different philanthropists who've invested literally billions of their own dollars in this effort. I've heard from all of the, not all, the vast majority of the national cancer institutes in my country and abroad. I've subsequently met with over 220 oncologists and researchers and folks in the field. And the one thing that I was dumbfounded by is that I've also heard from literally thousands of cancer survivors who, I go home in my home constituency where I was a senator for a long time, and standing in line to pick up groceries, people coming up and saying, thank you. I want to make it clear to everyone, I know I can be nothing more than a catalyst here. I'm the repository of little or no expertise in this area. but I have been, at least in the confines of my country, relatively good at convening people and bringing folks together. And the fact of the matter is, I've learned through personal experience with the help of a number of brilliant scientists and doctors, like many here today, that there are multiple disciplines needed to attack this disease. I know that's tough for the average person to fully appreciate, because when they think, and you talk about a moonshot, they think of one of these brilliant scientists in a laboratory finding a silver bullet that's going to cure cancer. But it is so much more than that. It's immunologists, geneticists, virologists, people, molecular biologists, scientists, technology companies, adept in supercomputing and aggregating big data, practicing oncologists who are on the front lines delivering care with not enough access to information. And by having subsequently met, as I said, with hundreds of the world's top cancer physicians, researchers, and philanthropists, technology leaders, cancer organizations, there seems to be a consensus around several issues. One, that we are at an inflection point. A great deal has happened just in the last decade or less in the fight against cancer. Research and therapies are on the cusp of incredible breakthroughs. And just in the past few years, we've seen some amazing advances in technology and science. And immunotherapy and genomics and combination therapies are being leveraged in a way they weren't being leveraged 4, 5, 6 years ago. And today, with us today is Dr. Jennifer Doudna, whose work is helping us read our DNA and our genetic makeup. Dr. Patricia Hammonds, who is developing nanoparticles to deliver therapies to resistant tumors. I met with 3 days ago with Dr. Carl June, who's one of the world's foremost researchers in immunotherapy. Dr. Collins here, the NIH, led the Human Genome Project. And there's a whole range of disciplines that, unlike 5 or 10 years ago, are becoming interdisciplinary. Secondly, almost every cancer center keeps a database of information, genetic history, medical records, and tissue banks that might hold the key to certain cancer therapies. But tapping this treasure trove of information is vital to speeding the pace of progress toward cancer cures. I've met with former governor of Utah, John Huntsman, of the Huntsman Cancer Institute, who brought to my attention that the Utah population database that includes complete medical records from cradle to grave, including genetic profiles and cancer diagnoses for going back years and years and years. With advances in supercomputers making a billion computations per second, going through tens of thousands of miles of fiber optic cable around the world, this data is a treasure trove, an absolute treasure trove that is being synced up now for the first time in human history. If we aggregate all this data in one place that's readable and accessible for scientists, researchers, and physicians, then the consensus is we can, in fact, speed up research advances and improve access to cures. But some argue that we could do more if this information was more widely shared and available. That's one of the questions I'd like to explore today with this panel. We're going to make sure this information is being shared so an oncologist in Austin, Texas can access information from MD Anderson, a major cancer institute where my son was treated, but now has no access, geographically close, but no access. We're going to make sure that information being shared by that oncologists in Columbus, Ohio, can get information from one of the great clinics in the world, Cleveland Clinic, represented here by Dr. Cosgrove. Two major such undertakings are represented today. The American Society of Oncology has its Cancer Link network that partners with SAP, led by Bill McDermott, who's here. to harness big data and personalize care for millions of cancer patients. Also, the American Association of Cancer Research has Genie, led by Dr. Sawyers and Dr. Baselga, excuse me, doctor. You can call me Bidden. That's an international data sharing system. I've also met with the folks at Quilt with access to the national Lambda rail, which has 12,000 miles of fiber optic cable lines that deliver huge amounts of data at 1.6 terabytes a second. And another organization, Orion, founded by the Moffitt Center and the Ohio State University James Cancer Center, is bringing together data from 11 different cancer research centers. I recently received a letter from the President's Chief Technology Office, essentially recommending why not just have a single place for this data. I'm not sure that's possible, but it's one of the things I'd like to discuss a little bit. The President and I also received recommendations from the President's Council of Advisors on Science and Technology, made up of some of the most brilliant minds in the country, including Nobel laureates like you, Dr. Blackburn, and doctors from the Salk Institute. They recommended to improve interoperability between the systems, ensure accuracy, safe, and secure sharing of data. This is an issue I'd like to speak to today. There's also issue of privacy surrounding access to all of this. And right now, only 5% of all cancer patients in the United States, and I'm sure it's similar throughout the world, end up in a clinical trial. Most aren't given access to their own data, even in that circumstance. So I'd like to talk about some of the recommendations I've heard from other outside advisors and experts. What do we do to reduce cost? Is it possible to reduce cost for these clinical trials? And how do we expand access to these trials? Other questions need to be asked are, how do we get drug companies to take part in the solution and the progress we all want to make? Some are struggling with that right now. Should a person own their own genome and their own data? That's another question that is very lively today. But I'm convinced that together we can find a way to answer each of these questions, and in the process, I think we can end up developing game-changing treatments and delivering them to everyone who needs them. That's the goal, at least, of what the President and I are talking about, to double the rate of progress we're making in understanding and treating cancer. Our goal is to make a decade's worth of advances in 5 years instead of 10, and eventually end cancer as we know it. We're not trying to make incremental change. We're looking for quantum leaps. And as again, all with whom I've spoken to now said this is one of those inflection points where there's a possibility of making quantum leaps. The President asked me to lead this effort for the administration in areas where I can hopefully be some value added. One is raising in the United States federal funds. So we were able to do that, add another $2 billion of this fight this last year's budget, and I'm hopeful we can do more next year and beyond. Coordinating all our federal agencies, the NIH, the NCI, HHS, DOD, VA, the Department of Energy, the national laboratories, all of them have a part to play, and the President will be issuing an executive order shortly that the bad news for them, having them all have to answer to me. But I mean literally, not figuratively, because just like we did in the Recovery Act, because the one thing we can do is we want to get out of the way of all of you. If we're in your way, if there's any bureaucratic impediments we're presenting, and if there's any collaborative work we can do, we want to be part of it. And we've got some fairly adept and bright people in the government. Ernie Moniz at Energy is very anxious to get engaged. The Department of Energy and the national labs can play a part as well. And thirdly, to attempt to coordinate the private sector to share data and research and helping make this more collaborative. And again, where we are an impediment, where you view us as being somehow a bureaucratic stumbling block, I promise you I can clear the way. That's the only thing I can promise you, because I am very rude when it comes to dealing with bureaucratic blockades, as the Secretary can tell you, although never have I had any difficulty with the Secretary. But all kidding aside, I want to make it clear, we don't think the federal government is the answer to this. But we think the federal government can be value added, and we want to be helpful. We need your help as to what we should be doing that we're not doing. And we will not be shy to privately tell you where we think we need more help from you and how to break down some of these barriers. The one thing I promise you is that we will do our best at the federal level to make this not just a moonshot, but a priority. Aware, everyone will be aware this is one of the priorities for this administration this last year. So we leave the next administration in a position where there's even an ability to make significantly more progress by either cooperating with, helping, and/or responding to your needs. To break through some of the barriers to speed up progress in research, deliver treatments, and increase access to these new approaches for millions of people is the goal. And that's why I am here. I'm flattered that Dr. Schwab would suggest that we have this forum and that I participate in it. But my main purpose here is to listen. And I'll conclude by saying that while we may focus the rest of the time, I'm going to focus the rest of the time I have in office is only 12 months. The bad news for you all is I plan on making this a major part of whatever I do the rest of my life. And it's something everyone can be part of. Researchers, corporations, oncologists join in the effort and help us find a way to share data and collaborate. Parents and their families demand that they be active partners in care and research and access to their data and the ability to contribute research. Sign up for clinical trials. Clinicaltrials.gov has a list of those trials that are going on now in the United States. Tell your story. Everyone can advocate. Everyone can advocate with their political leaders for importance of funding and cutting-edge research. So I look forward to this discussion, and I look forward to coming back next year with Dr. Schwab's permission and reconvening this group or group like it so we can demonstrate that we have actually made some concrete progress in the last year, which would happen whether we had this or not, but as much progress as we can. Now I'm going to turn to my good friend, Dr. Francis Collins, the director of the National Institute of Health in the United States, and one of the first geneticists to map the human genome. And he's going to say a few words. I'm going to ask him to introduce the participants, and then I'm going to ask him to turn this over very briefly to Sylvia Matthews, Burwell of the United States Department of Health and Human Services, to offer a few words, and then I'd like to start the discussion. But again, it's a terrible way for a speaker to begin, but by apologizing for keeping you waiting. But I do sincerely apologize for that. Doctor, the floor is yours.
Well, thank you, Mr. Vice President, and we are thrilled to have you here leading this discussion at this moment, which I agree represents a real inflection point in our opportunities in cancer research. Not an inflection point, an inflection point. Let's be clear about that. There are opportunities that are emerging in immunotherapy, as has been mentioned, that are breathtaking in terms of their ability to take individuals who we thought had kind of reached the end of the line in terms of interventions and actually not just put them into what seemed like a temporary remission, but potentially a cure. There are breakthroughs in genomics where we can read the DNA script of an individual tumor and see exactly what's driving it and learn what genes have actually acquired mutations to cause those cells to grow when they shouldn't have and what we might be able to do about that. And all of this feeds into, as the Vice President has said, this idea of big data. And we need that big data to be accessible to all the researchers who have great ideas about how to use it. It's not enough to say we're in a big data era for cancer. We also need to be in a big data access era. And I'm sure we will be speaking about that as well. And NIH is strongly in support of this very important part of what we want to do next. I agree that what you have said is that we need not just to focus this on a federal government opportunity. We need partnerships with companies. I'm looking forward to my time at Davos this year, having a chance to speak to some of the companies that are very invested in this space to see what kind of new partnerships we could identify. And certainly, we need patient advocates right at the table. We are not talking about doing a project where the participants are subjects. They're actually partners, and we want to have that component very much as part of this. So, Mr. Vice President, you are helping us a lot by bringing the visibility to this. We're glad to be part of your mission control team. We will try to live up to your expectations. The Vice President has demonstrated that he's passionate and he's principled, and he's also delightfully unplugged, and we've all come to enjoy that, and I'm sure will be going forward. I'm going to very quickly, in lightning fashion, introduce the panel, although brief comments have already been made about them by the Vice President. I can tell you good news. I think it's good news. They've locked the doors, and we're going to be here until 5:40 because we started late, and we didn't want to shortchange the opportunity. I didn't really mean it about locking the doors, but we have the time until 5:40, so we don't have to truncate this discussion, given that we got a late start. So I hope we can have a lot of time for that. I'm going to introduce the panel and then turn to Secretary Burwell, and then it'll come back to the Vice President, who's very good at kind of bringing points out. So, quickly around the table, David Agus is Professor of Medicine and Engineering at the University of Southern California Center for Applied Molecular Medicine. He's a co-founder of a couple of companies. He's a noted author with a book on the New York Times bestseller list called The End of Illness, and he is a physician of considerable knowledge about prevention as well as treatment of disease. Next to him, Paula Hammond is the David Koch Professor in Engineering and the Chair, Department of Chemical Engineering at MIT. Her work involves self-assembling polymers, and that has applications to cancer in terms of films and nanoparticles for drug delivery. Next, Jose Baselga, who is the Physician-in-Chief and Chief Medical Officer of the Memorial Sloan Kettering Cancer Center in New York. His own research on breast cancer and treatment with monoclonal antibodies has been groundbreaking. He focuses particularly on resistance to treatment, one of the things we need to know more about. Next, Elizabeth Blackburn, who is, as of all of 20 days ago, the president of the Salk Institute. Prior to that, professor at University of California, San Francisco, the 2009 Nobel laureate for her work on telomeres and telomerase. To my right, we have Charles Sawyers, also from Memorial Sloan Kettering. They have good representation here. He is the chairman of the Human Oncology and Pathogenesis Program. He's the president of AACR, a member of the presidentially appointed National Cancer Advisory Board, and his work on targeted therapy, particularly that drug called Gleevec that you might have heard about, has been really quite groundbreaking, and he continues to study ways to do targeted therapy to overcome resistance. Next, Jennifer Doudna, who is professor of chemistry and molecular and cell biology at the University of California in Berkeley. She's a Howard Hughes investigator, and she is the face for many of us of this really remarkable development in gene editing using something called CRISPR-Cas9. Next, we have Bill McDermott, who's the chief executive officer of SAP, is the big data guru that we need at the table here, the world's business software market leader, SAP, and with market customer centricity, and we need that too. And next, my boss, Sylvia Matthews Burwell, the U.S. Secretary of Health and Human Services. Prior to that, the head of the Office of Management and Budget, and before that, important roles at the Walmart Foundation and as head of global development for the Bill and Melinda Gates Foundation. And finally, at the end of the table, Toby Cosgrove, Chairman and Chief Executive Officer of the Cleveland Clinic, a surgeon of a cardiovascular sort, Bronze Star from the Air Force for his work there, but at the Cleveland Clinic since 1975, where he oversees a $8 billion healthcare system. Those are the folks. Let me turn now to Secretary Burwell.
Certainly, and I'm actually going to start on the breaking down of the bureaucracy right now and just say, Mr. Vice President, thank you for your leadership. Thanks to everybody who's here. Let's go ahead and get started with this conversation.
Well, what I'd like to do is, why in the order you're introduced, if each of you could make a brief comment on what you think is the most important element that is needed in this effort. What are either the biggest impediment, the biggest opportunity? What do you see as the single most important thing if you could wave a wand, you would clear the way of or or increased focus on? When I start with you, Doctor, and then we'll work around, and then I have a couple specific questions.
Sure. I really believe that we're going to get a lot of the clues in data. We saw over several months ago, a paper came out showing that if you had a particular blood pressure medicine you were on and you had ovarian cancer, you actually lived significantly longer. This is something we would have never picked up in biology, but it was picked up in data. You know, we don't look at outliers in our space, and from the outliers, we can learn a tremendous amount. Another remarkable study came out earlier this year looking at elephants. Elephants are 40 times bigger than you or I, yet they get very little cancer.
That's the only thing I knew, for sure.
It's amazing, but they have a particular gene called P53, which is what we call the guardian of the genome, that corrects DNA errors. You and I have one copy, they have 20. And so they evolved away because they have to live until they're 60 or 70. Women give birth in their 60s as elephant. Men protect the herd until the day they die. So evolution figured out a way for them to be productive. Evolution said, hey, listen, once we get 30, they no longer need us. We've stopped having kids, we use resources, and so we have to figure a way to go around that.
Very disappointing.
And so looking at these outliers in data, but in order to do that, the big impediment is data standards. You call it a broken leg, I call it a fractured leg. It's shocking, but we don't have data standards. We don't have data standards in how we collect data, in how we look at data, and how we term data. So somebody needs to take a stand here, a stand in the ground, and allow the data to actually yield the answers. Without them, we ain't going to get that far. They did it in the internet. They had 11 people in a room who said, here are the standards. They argued at the end of a long marathon session. They had it. We need to do the same.
I want the press to hear this. I find it when you go home and talk to your friends about a cure for cancer or changing the face of cancer, I'll bet you lunch that none of them say data, standardization. And this is one of the things we want to make sure that I want everyone to understand the component constituencies needed to be able to make the kind of breakthroughs that we needed. That's very, very helpful. And I love you, Doctor, because Sylvia always is kidding me. I say, look, don't speak Washingtonese to me. Speak plainly to me. You're speaking plainly, straightforwardly, that everybody can understand exactly why it's important in the examples you've given. This is an important step in bringing together and eliminating a lot of these silos that exist out there. But thank you. Doctor.
Yes, thank you, Mr. Vice President. I'm very excited about the concept of personalized medicine and what nanotechnology can do to enable it. I think we'll hear from our other panelists about a number of the different technologies that have been developed, everything from genetic circuits to new kinds of biological macromolecules that can actually change the course of cancer. One of the things from a chemical engineering standpoint that I'm excited about is the fact that we can find ways to package these systems and deliver them. There's a real challenge in actually getting the drug through the body and to the tumor. And this challenge has prevented us from using a number of our known, very effective forms of therapy. So one of the issues is how can we get something that is potentially toxic through the body and to the tumor? And that's something that nanotechnology has provided. By packaging systems in a nanoparticle that can travel through the bloodstream and accumulate in the tumor, we can actually protect the body while getting the drug to where it needs to go. We can actually design these nanosystems so that they are intelligent, recognize or bind to cancer cells specifically, and can be highly selective. And we can also design them so that they can create synergistic combinations of drug A and drug B that alone don't have real impact, but together have very high impact. And by being able to do this using nanotechnology, using nanoparticles, using other forms of nanosystems, we enable a huge amount of these very promising technologies to develop. One of the really exciting things I think right now is the possibility of using siRNA that silences genes and using genetic circuits that can actually alter genetic pathways. All of these are molecules that degrade in the bloodstream, but nanotechnologists scientists such as chemical engineers, material scientists, chemists, can work with biologists and clinicians to do this. So being able to put personalized medicine in the forefront and allow people to work together, I think is important.
Again, part of the reason having this forum is to educate the public at large. That's why so many of the press are here. And again, I doubt whether if you asked a PhD psychologist or a PhD philosopher, very bright people, what the role of a chemical engineer was in fighting cancer, it would not likely, and there would not be a ready answer. And I know with my son had glioblastoma in the brain in stage 4. And I know one of the things I remember hearing him talk about is the blood-brain barrier and how to break through. And it was all brand new to me. And the work you're doing is astounding. And I have a question for you when we get back, but thank you for your work. Doctor?
So thank you very much, Mr. Vice President. So the topic of data is going to be dominant here, and I'd like to give a couple of views on data. First, today we have more than 200, maybe 300, 400 tumor types. So it's just, we need big data because there are so many variabilities, so many differences in tumors. And these differences are being defined by the genome of every cancer. So cancer is a disease of the genome. And as much as important to know that a patient has breast cancer, it's important to know what genes are mutant, what genes are not working well, what genes are overexpressed. Today, we have the capacity to sequence the genome of every single patient, and we can do that at a very low cost. Less than $1,000, we could sequence every single tumor genome.
How recent is that, Doctor?
That is being cut by the year. So this has been happening the last 2 years, and next year, when we'll be back here, it's going to be $500, and that's the way it goes. But you see, today, only in sites like ours, like Memorial or MD Anderson or other that have philanthropic funds, can sequence these tumors routinely, and therefore, if we're talking about big data, let's assure that we can get the data before we put it into the system. So I would propose that we should find a way to reimburse, as of now, the sequencing of these tumors, because it's giving us critical information on which therapies these patients may benefit. And in some cases, some of these therapies are life-saving. We have examples of that. We just had a finding that was out in the press, very impressive, of a very rare type of tumor cancer, of brain cancer, that had one mutation on one gene, BRAF, and that responded well to this therapy. So I think that's one component. I have another observation, if I may, and that speaks about the need for artificial intelligence and the need to have computational power to help us. I'm in a place where we have 1,000 physicians, and you might argue that maybe they are not great, but they are okay. And some of them maybe even good. For their lives, these physicians cannot understand what is going on. They cannot understand what mutations are present in a patient tumor. They don't even know what clinical trials are open. The problem of clinical trials is not only that they are expensive, but physicians and patients are not aware of them. So if we could create, and that's a priority, if we could create information systems that would be user-friendly, that would inform our patients of what does it mean to have these mutations, what does it mean to them, what does it mean for the physicians, that the point that David was making, we should really, I think of all the fields in the economy, I would think that medicine probably is the one that is left behind in all this revolution of computer science, and we should do something about that.
Thank you very, very much. I want to get back to that as well. Thank you. Professor. Doctor.
First of all,
Madam President.
First of all, Mr. Vice President, thank you so much for committing to this incredible responsibility that we all have, and this incredible moonshot. I want to take off from the big data point again and go even further. You asked about what are some big impediments. cancers are a huge impediment. When they're diagnosed, they're highly heterogeneous. They're like wily ecosystems changing all the time. So we need a very dynamic big data collection of each person's tumor, and then we need to deploy this as well as we can. And that means not only sharing, and I fully support the sharing of the knowledge and the information among patients, between patients, with the clinicians, but also as the cancer is evolving, we have to understand what's going on. This means promoting ways of sharing the data with the scientists who can go in and try and work out what is going on as these cancers are evolving resistances all the time, because we're not there yet. That's a big challenge. We've come a tremendous way, but it's a tremendous challenge. And so I think the first point I wanted to make is data sharing, absolutely crucial, but extend this, find ways we can extend this to the scientists and keep this very vital cycle of bed to bench to bedside to bed. We need to keep that cycle very active because the cancer is evolving for each patient. And the second point is we haven't talked about very early stages of cancer. Cancer takes often years to become clinically apparent, and by the time it does, it's highly heterogeneous. If we can intercept cancer very early, if we can even prevent it, that's the way that I think we could really start to talk about the possibility of curing cancer. Everything else we've talked about is often containing cancer, which is a very good approach and realistic given the nature of the heterogeneous cancers that exist in, one person has great heterogeneity of the cancer. So I think this is very important to think, how could we actually cure it? Well, if we can catch it early enough before it's taken on all of these very, very difficult properties of being resistant, this might actually lead to the possibility we could cure it. This means real technology development, taking the understanding of the biology, which has gone so far already, to earlier and earlier stages. So I think really thinking about how we deploy resources into this other part of cancers. To me, I think of it, it's like two hands clapping. Treatment is vitally important, but unless you can prevent and intercept early, only then will you have the impact with the two hands clapping. So those are my two big points that I want to expand on what the other members of this panel have already said.
I think that's really important. I'm going to come back to it. I'm going to ask you about vaccines and the discussion of vaccines. And I don't know what your experience has been, the audience, but when the diagnosis came relative to my son, I thought there was a cancer, and it was an identifiable cancer. It was a single thing. You identified it. You could either stop it from growing, or you could not. And I'm being overly simplistic. And then I remember when the genome of the cancer was presented, and they showed me under a microscope, there were scores and scores of cancers, and that were in one cell. Again, I don't think most people realize that, and that's why there's more and more focus on vaccines and prevention and so on. So again, I apologize for trying to use you as props here to try to, because when we get approached in a political sphere about what to do about this, it's important that we be educated and the public be educated about just what is the nature of the problem. And but at any rate, thank you, Doctor, and maybe we can talk about vaccines a little bit later. Yes, Doctor.
Mr. Vice President, I really want to, again, thank you so much for bringing attention to this. I know it's personal for you. It's personal for me as well. My mother died of a cancer 5 years ago that is completely preventable today. It's because the pace of science could have moved faster. It happens to be related to your point about infections. Hepatitis C is now curable with a 2-drug combination. It is a disease that led to liver cancer in many people. I also thank you for plugging the Genie project earlier, and I have more to say about the big data topic, but I want to, because we haven't talked about this except briefly, was your point about combination therapy. Yeah. And I think the hepatitis C is an example. So my experience for the last 15 years, as Dr. Collins said, started with Gleevec, which is one of the best poster childs for targeted therapy. We now, 15 years later, have 30 or 40 or even 50 different targeted therapy drugs. And there's lots of science going on in our labs and labs around the world pointing to very strategic combinations of these drugs that could be used. And it's starting to happen. But I think the point I want to make is perhaps particularly appropriate at an economic forum, because there's an economic incentive component to this that's quite powerful and frustrating, and I think there's something perhaps that you could do.
Speak to this, doctor.
So a typical scenario that I've seen again and again is that company A will have drug A, and company B will have drug B, which they've developed for their separate reasons that all make sense, and both are viable products and could make it on the marketplace. But there's some science that says add A plus B together. And company A and company B can, of course, collaborate, and sometimes they do. But what I've seen more often happen is company A will try to get a copycat of company B's drug, and company B will try to get a copycat of company A's drug, or if company B is small, company A will acquire it, all these things. So it's clear there's a public good here that needs to happen, and I think it could be done by just realigning a few incentives. And I don't know exactly what they are, but one perhaps federal agency that could do something about it would be the FDA in terms of accelerated approvals for combinations. And the real sticky wicket here is, could you somehow improve or extend patents or push off patent expiry dates to incentivize companies to come together?
I was not going to mention drug companies initially, and that's not a pejorative comment. I mean it sincerely. We had a meeting with 25 of us at my home, including there were 3 large drug companies represented, and the head of the FDA as well. And the head of the FDA made a commitment they're going to move much more rapidly in approving combination drugs. But it was interesting that these, I won't mention them, but the 3 drug companies that were present all said they were open to a different way of doing business. Now, we've not gotten there yet, but at least there are. I think most people would be very surprised to realize that there are and my understanding, and you all correct me if I'm wrong, and I very well may be, it's really only been in the last 3, 5, 7 years that combination therapies have been much more focused on and hold much more promise. And that's created this new dilemma with drug companies arguing there's not enough movement quickly by the FDA to approve. We're going to take care of that. But also this resistance of, not my drug. I have an economic incentive in this, and I'm not going to be engaged. And that's going to be harder for us. It is a political solution, I believe, that's rational, but it's going to be difficult as we deal with this issue of patents and the like. But it is something that I think we're going to have to, and again, this is not an attack on the drug companies. Thank God they're doing it. They spend a lot of money, and so I'm not suggesting that, but there's got to be some way in which to break down those silos where you all have indicated makes sense.
If I could just add, I think that breakdown is starting to happen, but you could help it happen faster. The NCI has this match trial, which has now more than a dozen companies that have agreed to make about 30 different compounds available in this kind of combination therapy in a adaptive trial. And I assume, Charles, you would be in favor of that kind of model where that we have at least started the effort to get beyond this resistance that you mentioned.
Thing in solving the problem is recognizing the impediments, and this is the first time I'm aware of that we are so frontally addressing this potential dilemma, and I'm looking forward to working with the companies to do that.
So, Mr. Vice President, I'd like to join my colleagues in thanking you for calling attention to this important issue. My life has been touched personally by cancer, as many of ours have, and in fact, when I was a child growing up and thinking about going into science, I first got excited about doing biochemistry because I thought it would be exciting to be able to address the underlying basis for cancer. But I grew up and I became a scientist, but I actually did not become a cancer biologist. And I'd like to draw your attention to the important role of fundamental research in leading the way, in many cases, to discoveries that turn out to be critical for human health. So in my own experience, as you know, and as we've heard from people around the table here, the availability of human genome sequences is wonderful. The cost is dropping rapidly. That opens the possibility of real personalized medicine. The challenge has been, how do we harness that information? How do we understand it, and how do we use it to both understand and eventually to cure disease? And so in my own research, we came across, through a curiosity-driven line of work that was an international collaboration, we made a finding that was really focused initially on how bacteria fight viral infection, but led to realization that we could harness that molecule as a technology for rewriting genomes. And this is the technology that's now widely known and appreciated as CRISPR. And the way this works very briefly is that it basically involves a bacterial protein that can be programmed to recognize a particular sequence in the DNA of a cell to trigger a site-specific change. So it gives scientists now a tool that has the precision of a scalpel to make very precise changes in the DNA of cells. And what this does then with respect to cancer is, I think, two things. One is that it gives us a technology that is really increasing the rate of fundamental research into the underlying genetic basis for cancer, as well as to the targets of therapeutics. And we think that in the future, it's going to be possible to use the CRISPR technology as a therapeutic in its own right, but fundamentally there, it's going to require the work of people like Dr. Hammond, who are understanding how to deliver this into cells effectively.
Maybe if we have time, when we come back, you'll be able to speak to how does this differ than what people have seen, at least in the United States, and a focus on 60 Minutes on the use of the polio bacteria, the polio being injected into tumors. And in my son's own case, because it was the last thing, using PD-1 and a bacteria injected into his tumor in his skull. How does that relate to what you're talking about? I'd like to, because a lot of people are asking me, and it's becoming more knowledge, Duke University studies, MD Anderson's, but you're talking about several dozen people who have been through these trials, and it'd be useful for you to explain that a little bit. Bill?
Thank you very much, Mr. Vice President. I too have.
Sorry.
Thank you very much for your leadership, Mr. Vice President. I too have lost my mom. Cancer tried to take my wife, and my deepest condolences on the loss of your son, Bill.
I don't mean to make this personal about my son. It's way beyond my son. I was just using that as an example. Thank you, though. An example of the kind of questions an ordinary person asks when this happens.
Absolutely. I think it intensifies the battle, and we got to get cancer. I've got a couple of points. The first is I think we need to solve the problem with the patient in mind. So personalized medicine is a nice term, but customer-centric services is also good. Anyone who has been through this process knows that the process is broken. First responders, nurses, doctors, surgeons, researchers, these are the salt of the earth. They hold the whole program together. But you have a situation where everything is built on broken medical record system. So you have all kinds of staff loading information into a medical record that is too hard to use, nobody likes it, and all the staff and all the money is going to that. And really what happens is the unstructured information, like voice and text, is how the doctors operate with each other. So I think if we take a really patient-centric view of the world, just like all the other industries have, healthcare has a chance to really improve. So a couple of things that I would mention in focusing on the patient. One is this idea of genome sequencing, electronic health records, clinical trials, and then research. So the technology today, like SAP HANA, for example, with ASCO and Stanford and NCT in Germany, is already working. And the technology is in place. Mr. Vice President, you hit the nail on the head. The problem is, how do we aggregate the data in a way that it's retrievable by these massively significant new modern systems like SAP HANA, because they're already working. And this can give breakthroughs at a much lower cost in healthcare, and it can really help patients either live a longer lives or certainly give the researchers in the medical community the ability to kill cancer altogether. The problem is the data.
Thank you. Toby?
Well, there's been a lot said, Mr. President, Vice President, and I appreciate the opportunity for you to bring us all together and to contribute. One of the things that I think we all dislike about cancer is cancer itself, and the chance to begin to cure it. Probably best that we prevent it. Right now, we continue to do a lot of things that are destructive and are causing cancer. Smoking is 22% of the people in the United States and rising, and it's the most preventable cause of cancer that we have. Obesity is now 30% of the population in the United States and rising, leading to an increased cancer rate in colorectal, breast, and several other cancers. So we need to prevent cancer to start with. Secondly, early detection. We have not optimized our screening yet. The screening right now for colorectal is 60%. For breast, it's 70%. For cervical, it's 80%. There's a tremendous disparity between, based on economics, and people who do not have the wherewithal to actually get the screening are 50% as opposed to that of the others. So if we could screen early, we could cure a lot of cancer. If we could prevent a lot of cancer, if we could begin to approach these, and I think back to the analogy of two hands clapping. Certainly, prevention and early detection are one hand of the curing of cancer on the other hand.
Well, we have about another 15 minutes or so. Doctor, I'd like to go back to your point about, and I ask a question of all of you. In this big data area and aggregating all this information, how important is it that there be data standards? I was amazed, again, from my own experience, seeing records within my own family being cataloged two different ways and not able to be accessed. It was an interesting phenomenon. It's a long story, but how important is it to be, for lack of a better word, a common language, a common vocabulary?
We certainly.
What should we do about that?
I mean, we need it. I mean, clearly, there are lots of data standards. They're all good. Somebody has to stand up and say, this is what we're going to do. But it actually even gets deeper. Cancer is what we call a complex system. If you sequence the DNA of the eyelids, the only place you don't put sunscreen on, you find many of the DNA alterations of cancer, yet there's no cancer. So in order for cancer to happen, you need an environment that makes it happen. You drop a match after it rains, nothing happens. You drop a match in my home in Los Angeles, it goes up in flames. So how do we even describe, what's a data element to describe the system? We don't even know. So we really need someone to take a leadership role here and to really start to say how we describe the genomics that they're all talking about for precision medicine. How we put that, how do we collect it? How do we sequence it? What are we saying a mutation is a mutation? It's a whole new area, but somebody's got to take a leadership role.
The reason I asked the question, do you all agree with that, or how important do the rest of you think that is in terms of this issue?
I think the science word for that is the microenvironment of the tumor cell. But and I do agree, it's complex. But I'm more optimistic that we can get to near-term standards. But I want to make one point. I don't think we have one language across the world necessarily. Maybe for DNA standards, for reading the sequence, absolutely. Yeah. And actually, there's an international organization called the Global Alliance for Genomics and Health that Francis and I have both been a part of, that's taking a leading role in trying to more than have that conversation, but lock down the standards. But in terms of the points about broken leg or fracture, there's ways to have a set of commonly used terms get cross-referenced against each other. I know this from this Genie project that you mentioned, where there's just 7 institutions, but one in France and one in the Netherlands. And it's not possible, at least for me, to convince people in Amsterdam to use the Sloan Kettering format for coding a broken leg. So I think we have to be flexible but firm with translatability.
Yeah, I think I totally agree with that. We're doing pretty well, actually, with the genomic part of this. In a way, that's the easiest part. It's digital information, this alliance that Charles just mentioned, the
It's
Global
also,
Alliance.
quote, the newest.
Yeah, maybe.
You know what I mean by that? In other words,
We don't have the same legacy of
Yeah.
trouble. Yeah, you're right about that.
think.
The phenotypes, though, that sort of describe the medical history of an individual, much more complex to figure out how to represent that in a standardized form that would be agreed upon across the world.
The FDA did it. I mean, so the FDA 4 years ago established data standards for submission of drugs, and everybody has to use the same terms and the same language to submit it. So it is doable. Harmonization is possible, but I don't think it's optimal.
I'm just a lawyer, but I agree with you. But I became an attorney because I wasn't qualified to do anything else except be a senator and a vice president. So, all right, the other thing is that I wanted to ask about is what I hear when we talk about big data. Let me back up. There's at least 4 of you around this table are involved in a discrete project to generate as much big data as you can. Now, it's easy for someone outside to say, why are there 4 of you? And I know of another one that we met with Dr. Sunshan. That's right? You know, he goes out and purchases, you know, NASA. But I'm being a bit facetious. But seriously, he has an incredible network. This big data also needs fiber optic cable to get it moving. I mean, is there in the I don't mean this the wrong way. In the industry, is there discussion about harmonization beyond the 20 or 30 or 50 or 100 or 5,000 or 15,000 oncologists? Is there discussion about one gigantic repository that, and when I raised that before with others, they talk about privacy. And I hear that from some of the insurance companies as well, I hear that. But there's no requirement you put my social security number down. There's no requirement you use my name. I don't understand the privacy argument. Can someone speak to that? I know NIH is a little worried about the privacy side, but tell me what from the industry standpoint, from the scientific community, what is this argument about the reluctance to share a lot of this data based on privacy? Is it real, and is it, Doctor?
I think Charles could make the point. I just make an opening statement. I don't think privacy is of concern because we can clearly de-identify all the information and yet share it. That's how we do it in our projects. Right. I think we are at the moment, that's my vision, but Charles could provide more depth, is that we are at the pilot phase, you know, like with Genie, we are just a number of institutions. We are just trying to learn.
How many institutions?
Seven. But we just launched this, and we're just trying to find a way to work together and to identify some of the hurdles that are there. But you're absolutely right. I think in principle and in philosophy, we ought to do it all together and get the data. I don't see a privacy issue. We can work this out, clearly. We are even now obtaining germline information from patients and they sign consents, and we can share that. So I think it's more a logistical aspect than philosophical. And Charles, I'm wondering if you could give your view on this, because you've been talking about that.
To you.
Yeah.
By consenting the patient to share data, you get around the privacy issue. The reason there's so much concern is it is possible, even by de-identifying, to identify someone based on their DNA sequence. So that's been proven. Yeah. So, but what you can do is you can mask parts of the DNA to focus on areas of interest for the research question so that the entire world is not able to see that person's DNA. And that's another thing that this global alliance is trying to work out the systems for.
Sylvia, is that what you were going to speak to?
That is the issue that gets raised, that it can't be identified. And so that is the issue that is raised. I do believe we can figure out ways to make sure that with consent and then with figuring out when research is done, if you need to de-identify certain elements so you don't see all, you see what you need to do the piece of research you're doing. So I think there is a path, but that is the issue that does get raised.
If I could just point out, there's a nice connection here with another presidential initiative, which is the Precision Medicine Initiative, which is in the process of gearing up to enroll 1 million Americans to take part in this prospective study where their DNA sequence will also be part of a database. And we have the same questions about privacy and security, and I think we have a good path forward about how to make the information that researchers need to make discoveries present, but not put that at risk for the individual who doesn't really want every high school student poking around their genome.
Toby, you were going to say something.
You know, it's not possible to take and reconstruct from a piece of DNA what someone's face looks like, the color of their eyes, and you can begin to have huge implications from that.
One of the things, Mr. Vice President, you can totally anonymize the data. So anonymizing the data so you get the best of all the medical researchers anywhere in the world is a great way to provide precision medicine to the individual patient. This is something that's happening right now. You brought up a great point on the Social Security card. Why is it that a patient can't just choose to give their Social Security number and provide their data and have that data stored in a cloud file so it's easily accessible by any doctor, any surgeon, anybody that's helping them out? I think everybody would opt in for that. And that seems so simple. And yet that's something that I haven't seen anyone act on, and I think you have a great idea there. It's a winning idea.
Well, you give me credit for an idea I didn't have, but the idea was to get access, and that's the generic point. One of the things I wanted to ask, and we're running out of time. You're probably happy we're running out of time. I wish we could do this for another couple hours because it's really one of the jobs. Look. One of the things I've noticed that a lot of the researcher colleagues have done is to show that attitude impacts on recovery sometimes, and that has a lot to do with bedside manner too. So I don't want to get into that whole area, but one of the things that those of you who are incredibly good at what you do, and those some are even better because you're able to take this complex set of circumstances a patient is facing and explain it to them. Give them some reassurance even and let them know that the chances are, I had a couple aneurysms. They were very nice explaining to me that I had a 30% chance of living. I felt good about it, the way it was done. But my generic point is this. What would happen if, and I'm not going to do this without your permission later, and I'll talk to you all over the next month or so. What would happen if I asked for it and I could do it in private? All of those of you who are engaged in the acquisition and the storing of this big data, if I got you all together in one room, I mean, is that something that makes any sense for you all to talk to one another? I mean, in a fora that. Well, with your permission, I'm going to ask you to do that, and not for the cameras, not for public, just to educate me a little bit. And it may be that it makes no, anyway. But look, there's so much more for us to discuss here. But what I was trying to do at this incredible fora is just begin to sort of open the lid on what are the significant elements that play into this thing we've been talking about since, in our country, since President Nixon and a moonshot? There's so much change I've observed happening so rapidly. And I don't even think these people refer to stovepipes. I don't think they're even intentional. I just think everybody is sort of finding their way right now. And with your permission, since most of you are stateside, I'd like to be able to call on you over the next couple months and continue to help educate me, because what I have to be able to do, my job, the job of an elected official sounds presumptuous, is to educate the public in straightforward, simple language as to why I'm going to be asking them for a lot more money, a lot more of their tax dollars, a lot more cooperation, so that they understand what we're talking about. That it's not just one of you brilliant scientists in a lab looking for that silver bullet that's going to solve the whole problem. It's part of, part of it is, Edmund Burke once said, when asked why should he respond to whatever his constituency asked, he said there are two parts, I'm paraphrasing, his responsibility. One part is to reflect the opinion of your constituency, and the other part is to educate. Educate. You're sent there to supposedly master aspects of public policy that somebody working 12 hours a day just putting food on the table, they're smart enough to do it, but that's not their total focus. And so part of this is education. And the beginning of it was to help educate me, which I have a lot further to go. But I'm going to need you to help at home in coalescing people around what everybody seems to be coalescing around, that there are 4 or 5 big pieces to this that can be assimilated in a way that we maybe be able to begin to change people's lives around the world. I'm told time is up. We're actually 3 minutes late, which means I'll be expelled from the conference. But thank you all very, very, very much.